David writing on the board, rather 2B, going from rad to degrees. So,
Wait. Can I go?
you can do the next one. You can use the calculator, you can reduce it.
Oh, I was kidding. Yeah.
Hey, what's 45 divided by 1?
45.
Yeah, so
Okay. Do you want me to put it in?
yeah, they won't leave it as that fraction with that fraction squared. All right, good work. Pause for me, please. Please record again. Now, as you guys have seen, these are your free ones when you get to when they check your skill set on the assessment. So, if yeah, but again, no stress today. Today's the first one. I'm a nice teacher, it's like goes with 6. 6 is a good choice. Up is going to be a 2. And the bottom is going to be a 3. Okay. You pause it. These are the numbers and the answer at the same time. What you will start to feel is this thing about reference angles, and you start to feel something here. What do you notice about all 4 sets on the board? Is there a pattern? Something that's connected. When you look at all 4 sets of number, the 150, the 30, the 6120, is there something you notice about those parts or how they relate to each other?
Oh, they're reference angles?
They are reference angles. That's one connection in terms of pattern. There's another one that I'm looking at that I would want you to say. And actually, it has to do with the word supplement. That word in geometry means something. Anybody remember in geometry what supplement may mean when you hear that word? And I should add, as whoever's watching this at home or listening to it, that's why this vocabulary is important to me. Not because you should be able to find a supplement, because I don't want you to, but at least I want you to know what they're asking. And when I hear the word supplement, something pops into my head. Anything pop into your head when you hear the word supplement or supplementary? Okay.
That's the added to 80.
Yeah, add it to 180.
Oh.
And
It's
so-
a bit of, oh my God.
And so when you see that word, which isn't one of ours, that would be in geometry's word, geometry A, notice the 2 of these, they add up to 180. This guy here, if you were to add them together, he really would do it. And even this dude over here, he would add up to 180. So when things are supplementary, they add up to 180. And the way it looks in picture form, we're trying to get to reference angle because I think they're going to ask you something about a reference angle. When you see this, we know our normal friend 90, he's normally there, and 90 kind of helps us estimate when we're making our picture. 150 is probably like over here somewhere. I'll make him, and I don't have to be perfect, but I know he's past 90. Here is the concept of a reference angle. To go from here all the way to over here, it really is 150 degrees. The supplementary angle or reference angle asks you to get down here to your 180. To get down here, how much further would you need to go? Oh, I need to go another 30 degrees. That other 30 degrees is called the reference angle. How far are you above this line here? Well, if I were to show you this angle here, regular old 30 degrees, it's the same question. How far above this line are you? I'm 30 degrees above. The reference angle just says this. All the heights that you could ever possibly be above the x-axis will be between 0 and 90. You can never be higher than that. Like when you get up here to 89 degrees, well, the minute you pass here, at 91, you're still 89 degrees above the x-axis. It's a weird way to say it. I don't know how to say it. But I'm going to show you the 120, and I'm going to ask you to sketch 135. I'm going to ask you to sketch 95. Well, how do you sketch that? 120, you know where 90 is. 120 is past 90. Again, I'm just saying, so what if I'm wrong in terms of the actual picture? If I know this is 120, the real question is, how much more do I need to supplement it to get to 180? I need 60. And this 60,
So it basically does tell us.
it does say reference angle.
Oh, wow. But that's strong.
Yeah, sketch these other two just so that come 120 degrees is equal to 2 pi over 3 by doing that work. This is the answer that you would get if this were a unit circle. Unit circle, of course, is just where the radius happens to be 1. But the question is, for this 2/3 pi, where's the pi? Pi is all the way over here. 2/3 pi is if we were to chop the whole top section into 3 separate pieces. I color in the first third, I color in the second third. 2/3 pi would be up here on a unit circle. That means I get from here, if I was eating the crust, I love the crust, this is how much I would have of the entire pie, the top half. The question you may be asked something to the effect of, this is on a unit circle. What if this circle, though, instead of just having a radius of 1, like we tripled it? Like, in this case, let me not triple, let me quadruple it, make it to the 4. Like, the radius is 4, so this pizza now is like 4 times the size. It's not this little baby pizza. The question they want to know is, well, how will increasing the size of this pizza increase how much crust you get? Like, what would you do if you double the size, if you triple the size, quadruple it? What would you do? Or what do you think would happen?
I don't think the number would still be the same. Because
Right.
It's still on the same degree.
Yeah. So in a way, on the picture, you would wind up kind of in the same place. But here comes a real life question. Say you buy a mini pizza from somewhere, and that's exactly where we're going to go. And you got the crust. You have a little piece of crust, though it would end here. On the larger pizza, while you mark it still here, the question is, how much more crust would you actually have on a larger pizza? If I double the amount of the radius, turns out I have double the amount of crust, actual crust. Though, if I drew a picture, it would still end here, but the amount of crust would be,
Would it be the same size?
No, there's one extra thing you have to do. And so I want you to feel first that the amount of crust you eat on a mini pizza really will be more, or rather less, than what you would have on 4 times the size. The question is, well, how do we write that in math talk? Oops, that should be a 3. How do we write that in math talk? And here's how we write it in math talk. If I double the size of pizza, I would have to double the crust size. Here's the crust size, so I have to multiply that thing times 2. I have to double the size of it. If the radius were 3 times the size, then whatever crust I found out on the original baby pizza, I'd have to triple the size of that thing. Do me a favor, write down what you'd have to do on the quadruple size. The radius is now 4. Write down that part and then actually try to work it out.
When you work out in the test, are they letting you use calculators?
I'm not having you use a calculator, but more for typing in the stuff. In other words,
Would they accept it like in decimal form, or would they want it still in fraction?
they will want it in fraction. In other words, what I'm going to do to this one, what I'm going to do to this one, and if you guys wrote it properly, what we're going to do to this one. Oops, it's going to stay as a fraction. The only way a fraction wouldn't be there would be in this guy's case. you're going to see why the fraction won't be there in that case. So here's what I think you guys wrote. I think you said, if I know the amount of crust on an original pizza, double it, that means multiply by 2. Triple it, that means multiply by 3. You quadruple it, I want a lot of crust. All right, but let me give you a second to see what you remember in the word in the way of the last guy. What was the answer to the last one you were saying?
Yeah, it was 800. Oh,
This is the degree, the reference angle, associated with 370 degrees. Let me ask it again. If I went around the circle 360, I'd wind up back at 0. Then, to get to 370, I just kind of keep going. Where would I actually end up?
2 pi. No.
I'm going to go with your thing in a second. 10 degrees is correct. There is a pi version of that, which I'm not going to use just yet. There's going to be a time we use that. But for now, is everyone okay with where he got the 10 from? It is 10 more at 360 degrees. So then let's make it a little bit tougher. Let's see if I can do this one in my head. Well, don't do an extra tough one. 360, let's make it 420. Go in your calculators if you need to find out at 420 degrees. Don't say it out loud yet though. Write it down on paper, that way I know you got it. Keep subtracting until you get a reference angle. A reference angle by definition is an angle between 0 and 90. So if you subtract and you get a number bigger than 90, you know you got to keep subtracting. All right, get ready for it. Please find the reference angle for C on your handout. For C on your handout. It's going to be on the back of the page. There are negative degrees. The negative sign just tells you which direction to go. In other words, if I were given negative 110 degrees, what it means is go 110 degrees, but in the opposite direction. Normally, 110 degrees go past 90. Oh, there you are. Negative 110 degrees, you start this way. Well, watch this. If I were trying to get to the same point, and I didn't want to swirl all the way around, what's the fastest way to get there? I can go negative 90 degrees, which is just some information to know. But what is it that he's actually trying to get us to learn on the test? They might do a thing where they go all the way around in radians and call this 2 pi. If they went all the way past that and stopped here, that would be 2 pi plus one more. This happens to be pi over 2. And you'd have to make that just one number. In other words, you'd have to add these two together. So you're like, well, how am I going to add this plus this? Just the way you add regular fractions. You put this over 1. You'd have to get common denominators. Oh, 2 is the denominator. So I multiply 2 on this side, 2 up here. So I wind up with 4 pi on top, and pause right there for a moment, over 2, plus the pi over 2. What will the top be? 1 pi plus one more pi will be how many pi's? 5 pi's all over the 2. Here, to get the first part, you'll have to write it as a fraction over 1. And whatever is at the bottom of that new fraction, that's what you're going to multiply to be the denominator. I just want you to hear that when you get to it there. Please find the exact value for the cosine of 60 degrees. It's on there.
Okay.
Oh, no, you need the actual cosine of 60 degrees and then the sine of 60 degrees. I'm going to do 30, which is on the board, and then that will remind you how to do the others.
I
So to do the 30 degrees, which is on the board, you got the only part you have to know is that the middle fingers are the fingers, the pinky and the thumb. You don't really need those. For the middle three, 30 degrees is ring finger, middle finger is 45, and the pointing finger, also known as the index, is 60. That part you have to know. So I'm going to do 30, you do the 60 for both of them. 30 degrees, ring finger. Top part is always the number of fingers inside of the radical, bottom is 2. And that's where this answer comes from.
How do you, okay, well, how do you get 2?
2, that part is just there. That is part of the formula.
So when we do everything, so it's 2.
Always over 2.
And then how do you get 3? The
Top
number of
fingers.
fingers on top. So if you got this one, 3.
Uh-huh.
If you got this one, 2.
2.
If you got this one, 1. Okay. I was confused. I was like, do we count the bottom ones too?
No. So the bent finger is like a comma. It's cosine, comma, sine. So again, there's cosine, and hopefully you can see sine. Pause. Either A. 60 is a 1, a 1/2. And his friend over here is radical 3. All right.
How does that one look, right?
What's the tangent of 60? It's flipping the fingers. And this is one that's tricky. When you flip the fingers, you actually use the numbers of fingers. Let me write it, see if you can feel it. I actually use the 3 for the top, and I actually use the 1 for the bottom. And they both start off in a house. And then the square root of that is just 1. Anything divided by 1 is just that thing. So go ahead and say it. Sure, we'll try it. Cosine of pi over 2. Cosine of pi over 2. Where's the pi button? Another pi button is on there somewhere. So on this one, of course, amplitude is right here, and then the midline is here. It's k. You said 2 or 150. Why the 2 or 150?
Because of the point from where the midline's at. Well, I chose a different midline. I chose 0.50. It starts from there.
You put your midline right here?
No, 0.50.
Right here.
0.50 below.
Okay, 0.50. This guy here?
Yeah, I put it right there.
Oh, okay, I see that. What you have to think, and I'm glad you chose that one, is the following. Because we're beginning here, in a weird way, you are choosing kind of the ground floor. Oh, no, yeah. If it were a roller coaster, I get it. Like, saying we started here. But since this one didn't dip, yeah. 2 down, 2 up. Okay. I see why you chose that. Let me ask you this. Can you feel why the 1 is the better choice?
It was between. It's.
No, she said the between thing is right, and that is the midline has to be a case where the heel that goes above the midline is the same amount as the trough that goes below.
Okay.
And that's how you can double check, okay, oh, you're a 2, oh yeah, that's it. With this one here, it would go up higher, and then the little part would go down lower. It wouldn't be the same. All right, so 1. Here comes the last one, and when hand gets on 8, no matter what, I gotta put it in your hand. Let you do something at the very least, see what's on there, do all the A's, and
So
let
what's
the,
A?
oh, A,
2?
oh yeah, it's actually gonna be the 2. So we'll put that there, or let's just erase it that we don't put 2. All right, so it is a 2. And then, all right, David, let's put in some stuff in the equation, and then I'm gonna see how you wrote, if you put it in, or even you could just tell us this is A. I'm writing it again, sine B. Why is he writing the whole thing? The more you write equations, the less you have to memorize them, because just the sheer fact that you keep writing them out puts it in your brain, which is why I want you to write them in. So here comes A, we decided was 2, could be 2, I'll put 2.0. And then sine, get that inside thing from David and just say, I'm going to put that B there. You know, technically the X is going to be there. Plus, it was a 1, no, it was a 2. All right, here we go. Hey, David, what do you think goes on the inside here?
It's 1.
Uh-huh. All right. He says a 1.0. So here, it's a minus and 1.0. For anyone who may not have chosen that one, can you see why it's a 1.0? They can say why you chose 1.0?
Just 1.0 because the origin spot is
Mhm.
0.0 and the wavelength was moved 1 over.
The rule is this: if they don't start it at the original, at the origin, which is normally 0, 0, that's where everything starts. Boom, the picture starts going from there. You have to tell another scientist, hey, this isn't like a regular kind that starts where it normally does. This one, it started over a few seconds, so like two people were running a race and the other person got a head start. You were held back. This one is held back. That's why he didn't win the race. It wasn't just because he's slow. He waited, up to 1 second, then he got to take off. So the rule is simply this: if they shift it to the right some, this number tells you how much it was shifted. There's a way to shift it to the left. Last thing I'm going to say, and then that'll be it, and you'll mess with it. Getting an A, a K, I feel like I want to give you credit there. Your amplitude, a good midline. I want to give you credit. They are going to shift it. So I want you to know that, but since we just talked about today, it might be a little bit tricky. The last thing I'm going to say is this. Every sine wave formula can be rewritten as a cosine wave. The only part that has to change is the h. In other words, this red line, if I wanted it to be this new equation, all I got to do is like slide it over and then it will match. Another way of saying that is this. Let me draw this picture for you, see if I can draw it. Let's see. No, I'm not going to do it well. Not going to do it well. Focus, you can do this thing. You can do this thing. 1, 2, 3, 4. If this were a cosine wave, it would have started up here. I'm doing the red one. If it was a cosine wave, it would have started up here. It would have gone... I can't do it. Try. The blue line is a cosine wave. Notice here, if this ridge here were moved over to right here, it would wind up starting here, it would go down here like that, and it stopped right back up here. Okay, what does that mean to them? Like, what is he trying to say to us? He's trying to say that the red formula could be rewritten this way. The red formula is the same thing as the blue one. They have the same amplitude, they have the same K. The only difference between them is one is shifted more than the other. So X minus, I shifted all the way over to like 1.50. Can you feel that a little bit? Here's what this is a B section question. This is a 4. You're going to get the formula, the original one. I'm about to pass your test out now, see what you can do in 17 minutes. And then they're going to say in section B, hey, I know you got an answer for the original one. Is there a way you can rewrite that as a cosine? And you were like, yeah. I'm going to write everything else exactly the same. I'm going to write the very beginning, except with the word cosine. I'm going to write the very end, The only part you have to change to make it a cosine, like you start at sine, the only thing you have to change to make it the new guy is you got to figure out, okay, the highest point on a sine wave is normally where a cosine wave begins. Cosine would normally start back here and go down. You need to get this guy to start at this point. So like, where does that start? Like, where's that highest point? The highest point is like at 1.55. Oh, 1.50. Okay, if I just move this cosine over 1.50, then this red line describes the same picture as the black line.
I don't get how you come 1.56.
Here, you see how halfway between here and here, that's 1.50.
Which one are you doing?
This blue line, I wanted to pick him up and move him over so that he's right on top of the red line.
That's so weird.
Yeah.
It's complicated. I'm gonna be long.
It's a B question. You don't have to get a B question. But if you decide to try a B question, just know whatever answer I get for A, to get a B, I change one number. Everything else stays the same you just have to switch from sine to cosine. But the one number you change is, okay, if I started here and I moved it over $1.50, now they're lined up. If this dot was above 1, then you'd have to move it over just 1. It's tough. You feel what's going on there with that idea or no?
The bottom one.
I gotta get it.
That's two.
Say it again.
On the bottom one, two.
This is for,
It has a sign. Wasn't it one?
this bottom thing was this line that you and Oswaldo did. Remember I would have to choose the midline? Oh, I see what you're saying.
Yeah, because I got confused there too. I was like, why didn't you put two?
No, you're right.
And
Good
then,
work. Yeah, so that's an error. Good work. That is the midline here. Because I put the 2 at the beginning.
yeah.
All right.
Because I was like, why that?
Yeah.
Wasn't
It should be what, 1?
One,
You okay with why it should be 1? Yeah, because it's the midline.
yeah. I was stuck on that one. There was some other stuff. I was like,
That's so good. You said